Good morning, students. Good morning to everybody. There. So I would like to start again the last part of the structural organization of animals, and this one we have to conclude the last one, a vertebrate, about the flow. So far we studied two invertebrates, one the earthworm and another one the cockroach. Now the third one, as an example for vertebrate, you have to go for this frog. You know that the frog belongs to a class Amphibia, animal which is leading a dual life. So capable of living both on land and in water. As it is not actually either in water or on land, this group, amphibian group, is called as a defeated group. So that is not able to live either on land or in water. They are one leg in water, another leg on land. That's why they are called as a defeated group. Now here is the systematic position of frog. Now it belongs to the phylum Chordata, and that to the vertebrate. Under the vertebrata, it is having a jaw that is called gnathostomata. The division gnathostomata, animals with the jaws. You have studied already the classification, animals with the jaws. As animals have actually 4 legs for movement, the superclass is called tetrapoda. Animals with the 4 limbs have 4 legs for movement. As animal is moving or just leading a dual life in water and on land, this group is called amphibia. The list amphibia, the living amphibians are grouped under list amphibia. The living amphibians. We have extinct amphibians also. The living amphibians. So normally the amphibians arose during one period in the geological time scale. The list amphibians arose during the Devonian period. One period, what is called Devonian period. That period is called as the origin of amphibians. Devonian period, origin of amphibians. Then Anura. That means these are all tailless amphibians and units without tail, tailless amphibians. Salentia, or the animals are able to hop on land, hopping, able to jump. That's why the group is also called Salentia. Then genus Rana and then Tigerina. So this should be in small letter. So because the species name always starts with a small letter, so Rana tigerina. Now the skin has patches of dark, that is color structures, and the body is normally olive green in color with patches of dark black spots, irregular spots, giving the appearance of the stripes of a tiger. Hence the name, the species name is given, what is called tigerina, Rana tigerina. Now this is the systematic position of frog. Now let's go for the next one, morphology. The entire body is covered with a loose skin, but the skin is richly supplied with the blood vessels, and also it is normally moist in nature to assist the process of respiration. Because when the animal is on land or in water, it utilizes the skin for respiration. Nearly 34 to 35% of respiration of the body takes place only through the skin. So the skin is without any scales, as in the case of in the case of that one. So like that, in the case of reptilian forms, we have the scales all over the body, like lizards, snakes, etc. But in the case of frog, there is no such. You have studied already in classification. We taught about it. So here, the skin is normally smooth and slippery. This is because of the secretion of the mucus by the mucus glands. The unicellular glands are present at the surface of the body, and that one is actually keeping the skin always moist. This is because of the mucus secreted by the unicellular glands, mucus glands. Unicellular glands, mucus glands. We have seen already, it is an example for apocrine gland. Mucus secreting cells. We have an example for apocrine glands. Now what is the nature of the body color? As I mentioned earlier, the body color is normally olive green. With the dark, you see that one irregular spots, dark spots which are formed irregularly, not having any specific shape or just having an outer edges. So it's being scattered all over the body. That's why the name is given tigerina. That's why the name is given tigerina. Now, one question came in the question paper. What is the reason for the development of skin color in frog? So we know that when the skin color, in our case, is produced by the melanin pigment, melanin. That melanin pigment is produced by the melanocytes. Likewise, in the case of frog, the skin color, the different skin color, the green color, is due to chromatophore. Chromatophore. That is a kind of cell which is concerned with the production of the pigment. So, this is one question came in the question paper. The coloration in camellia, you see, camellia, the one which often changes its skin color, and the coloration in the case of frog. So, chameleon, in the case of chameleon, the lizard, which often changes its skin color, and also in the case of frog, this the question came. The skin color in the case of chameleon and the skin color in the case of frog is due to the presence of chromatophores. Some structures present, the cells present, which produce what is called the colored pigment. In our case, you know that one, the brown-black pigment. The brown-black pigment, that's the melanin. That is produced mainly by the melanocytes. The same manner, in the case of frog, the color skin is produced by the pigment called the chromatophores. Now, the ventral side is pale yellow, only the dorsal side is olive green in color. Now, the skin is a main organ of respiration. So, it is not only assisting the respiration, but also it is used to absorb water from the atmosphere. Because the animal is never drinking water. So, in order to get water, the animal is now not drinking, then absorbing water from the external medium. So, the skin is hygroscopic in nature, hygroscopic. So, the most useful function of this skin is respiration. That respiration through skin is called cutaneous respiration. And also absorption of water from the atmosphere. Absorption of water or from the water body. So, two functions are performed by the skin. One, the skin respiration, other is called cutaneous respiration. And another one, absorption of water, because frogs never drink water. Frogs never drink water. Now, what are the divisions of the body? The body is divided into only two parts. One is the head, another one is trunk. Because the neck is absent in the case of frog. So, head and trunk, these are the two parts of the body. But no neck is actually present. Now, on the dorsal side of the snout, now this is what we have, the snout region. Suppose the head, we have the eye. Here there are two openings are present. Two openings. Now these are all called the external nostrils. On the snout region, just a slight projection of the upper and lower just together, the head is produced until in a small snout. On the dorsal side of the snout, we have a pair of external nostrils. That is above the mouth, a pair of external nostrils. Used for actually respiration. The animal is taking air through these respiratory openings into the buccal cavity and then to the lungs and assisting the process of respiration. Now we have a pair of eyes present laterally. Each eye has an upper eyelid and a lower eyelid, which are immovable. And connected to, just we see that one, the eyelid, we have a membrane, what is called nictitating membrane. Nictitating membrane. It can be drawn over the eye. It can be drawn over the eye. So normally this one is a continuation of the lower eyelid. So we have a nictitating membrane, a transparent, somewhat a transparent membrane, not completely, which closes the eye when the animal is in water. When the animal is diving into the water, in order to protect the eye is closed with the help of nictitating membrane. So the eyes are guarded by upper and lower eyelids and also somewhat a transparent nictitating membrane, not fully transparent, somewhat transparent membrane that protects them while in water, not fully transparent. Now on either side of the eye we have, see in the case of frog, the external earlobe is absent. Only we have the eardrum, it is in flush with the skin. So on either side of the eye we have the eardrum is present, not the earlobe. The earlobe, the external auditory canal, this being absent. We have only starting with the ear, that is what we have the eardrum. So on either side of the eyes, a membranous tympanum or tympanic membrane is present. It is concerned with the perception of sound waves. As in our case, we too have what is called the tympanum, but it is sunken in what we have the auditory canal. So we have earlobe, auditory canal, but that one is absent in frog. It is starting with directly the tympanum, which is in flush with the skin, in just actually superficially placed in coincidence with what we call the skin surface. Now what about the limbs? The animal is able to hop on land as well as swimming in water and also leaping. Normally the legs are used for swimming, walking, leaping, and also for burrowing in some cases. Now there are two pairs of limbs, the forelimbs and hind limbs. I mentioned earlier, we have all these limbs are used for either for swimming, particularly the hind limbs, walking, all the forelimbs, leaping, just all the forelimbs, but particularly the hind limbs, and also used for burrowing. That's about the function of the limbs. A pair of forelimbs and a pair of hind limbs. Now this is the organization. We have the eye. So the two openings, we have the external nostrils. These are the external nostrils, not visible here. The two openings, external nostrils are external nares, through which only the air is entering. Now we have the mouth. The circular patch, what we have the tympanum on either side. This is the circular patch, and that one is a tympanum for vibration, and that one is being vibrated by the sound waves from the external medium and conducting the vibrations to the internal ear. Now we have actually two limbs, the forelimbs and hind limbs. As usual in the case of all vertebrates including human, we have upper arm, forearm, and then hand. So the wrist and the palm and then fingers together called as a hand. Wrist, then palm and hand together called as a, actually that is what we call the hand. Now in the forelimb only 4 digits. Only 4 digits. But we have 5 metacarpals. Now the palm is supported by 5 flat bones, somewhat long bones, somewhat elongated, slender bones. They are called as the metacarpals. So 5 metacarpals are present, but we have only just what we have 4 digits. That means the first digit, the first metacarpal is highly reduced and the first digit is also absent. Now normally the first digit is the thumb. So the first digit is absent, the first metacarpal is reduced. So that we have 4 fingers and also we have actually 5 metacarpals. The first metacarpal is highly reduced. Now if you are taking the hind limb is long, strong, muscular, used for leaping and hopping. So in the case of hind limb, we have actually 5 toes. 5 toes. In the case of Rana hexadactyla, we have 6 digits. That's why the name is given Rana hexadactyla. But in the case of Rana tigerina, only 5 toes are present. 5 toes. And between the toes, we have a membranous skin fold. Now this is a membranous skin fold. You can see that is what is called the web. That one is assisting in water. That one is assisting in water. Now normally the frog is called Indian bullfrog of highly economic value. So it is normally called Indian bullfrog. Indian bullfrog. Indian bullfrog is normally fatty enough, bulging body, somewhat muscular, hence called as a bullfrog. Very strong body. Okay, now you have that one. If you are taking what we have the hind limb, we have thigh region, the shank region, the foot region. In the foot we have 5 toes. And between the toes we have a skin fold, what is called the bib, and that one is assisting the animal to swim in water. Okay, that's about the diagram showing what I described so far, the external morphological structures. As I mentioned here, the hind limb end in 5 digits or toes. They are normally larger and muscular than the forelimbs. The forelimbs end in what we have the 4 digits. So forelimbs have 4 digits, the hind limb has 5 digits. Now between the actually toes I mentioned about, we have the webbed toes. So feet have webbed digits that help in swimming. That's why it's acting as a paddle-like structure. Now sexual dimorphism. How can you differentiate a male animal from that of a female? Now, what is sexual dimorphism? The differentiation between male and female sexes. The differentiation between male and female sexes is called sexual dimorphism. Or we can say the morphological, anatomical, physiological and behavioral differentiation. Morphological, anatomical, physiological and behavioral differentiation between male and female sexes is called sexual dimorphism. Particularly we can say the external differentiation. Morphologically they are more distinct from one another. So the male animal can be distinguished by the presence of two structures. One structure present in the neck region just below what we call the vocal cavity or the lower jaw, a pair of vocal sacs. These vocal sacs are used for producing a croaking sound. So they are sound producing vocal sacs. They produce what is called a croaking sound. To attract the female during winter for copulation. That's the role of this one. So presence of a pair of vocal sacs, not vocal cords, vocal sacs. We have vocal cords in our larynx. The one which produces the sound, hence called as a sound producing vocal sacs. And number two, in the first digit, suppose we have there are four actually digits. In the first digit, suppose we are taking for example, this is the 4 digits. A symbol diagram is showing that one. This is the first digit, the second one, third one, and the fourth one. So towards the inner corner of the first digit, there is a pad of tissue. There is a pad. This pad is called what is known as a copulatory pad. This pad is called as a copulatory pad. So it assists in copulation. So these are the two major differences between the male and female frogs. Both the vocal sacs and copulatory pads are absent in the case of female. So we can see the copulatory pad in one of the fingers, that is the first finger. So on the first digit of the 4 limbs. So anyway, the differentiation is there between the male and female sexes, and that is called sexual dimorphism. Morphologically more distinct. A presence of a pair of vocal sacs and also a copulatory pad present in the first digit of the 4 limb. So I will show you now what we have. That is, this is the male frog exhibiting sexual dimorphism. You could see that one, this is the vocal sac. A large blue colored one is present here. It is normally a toad, not a frog. What is given somewhat actually, there is actually the forest frog. Again, the species only Rana tigerina, somewhat actually different from the toad. Somehow it is similar to the toad in structure. Now this is a vocal sac. Vocal sac present on either side in the angle of the jaw, concerned with the production of croaking sound. Now these are all the external nostrils. You could see the external nostrils. And now we have a pair of eyes, bulged eyes, projecting beyond the level of the surface of the body, upper lip, lower lip, and somehow transparent, what is called nictitating membrane. So this is an organization showing that is the vocal sacs. Now let's go directly to the internal organization, digestive system. You know, normally the insect feeding animal, it is carnivorous in nature, mostly capturing the insect and feeding on it. So we can say either carnivorous animal or we can say what is called insectivorous animal. Further, they have certain mechanisms in the tongue too. The tongue is normally long and bifid, divided into 2 terminal branches, and it is always kept folded when present inside the buccal cavity. At times of feeding, the tongue is flicked out. As it is sticky in nature, the insect is normally stuck to the surface. Now this is what we have, the tongue, which is bifid. It's called as a bifid tongue because the terminal end is branched. Bifid tongue, bifid, F-I-D. So that's about the nature of the tongue. Now, before entering into this activity of the tongue in relation to the digestive system, we have to know, so 2 components in the buccal cavity assisting what we call the digestion for grinding. But again, there is no grinding of food. We are grinding the food by using the molar and premolar teeth. But here there is no mastication in the case of frog. There is no mastication. The animal is capturing the insect and swallowing it. So, though Thus, actually, there is no mastication in the buccal cavity, but the animal has certain what we have the teeth. Now we have teeth present only in the upper jaw, and also a pair of teeth what is called vomer teeth. Now, what is the nature of the teeth? And then we will go far. So the teeth are called acrodont. The meaning for that one, they are directly attached to the bones. There is no gum. They are directly attached to the bones. That condition is called as actually acrodont. Directly attached to the bones of the jaw. Then it is also called homodont. All teeth are similar. Our teeth is called heterodont because we have 4 different types of teeth, different teeth. But in the case of this one, homodont, all teeth are similar in size, attached to the bones directly. That's a jawbone. Then polyphyodont. So our teeth called diphyodont. That means we have 2 sets of teeth developed during the lifetime. One set of teeth up to what we have the 6 years, the milk teeth. That is in the case of children. And that milk teeth is replaced by a permanent teeth in the case of adult. That condition is called diphyodont. So in the case of mammals, normally diphyodont condition. Now in frog, it is polyphyodont. That means several set of teeth are replaced during what we have the lifetime. Several sets of teeth are formed. They are being replaced again and again. Hence called polyphyodont, replaceable teeth. One set, that set is replaced by another set, and that set is replaced by another set during the lifetime of frog. But in our case, one set that is being replaced by another set. So entire life period, we have only 2 sets of teeth. One is called as a milk teeth, as found in the case of infants up to 6 years, and from 6 years onwards, we have a permanent teeth that is normally one which replaces what we have the milk teeth. So 2 sets of teeth during the lifetime, hence our teeth called diphyodont. This is diphyodont condition. Diphyodont. That is in the case of actually human being. But in the case of this one, polyphyodont, so several set of teeth are being formed during the lifetime, hence called replaceable teeth. Now, how I mentioned about the teeth are not present in both the jaws. It is confined to only to the upper jaw, and also we have attached to the maxillae. That is upper jaw. That is why it's called as a maxillary teeth. Upper jaw is called otherwise called maxilla, as the teeth are found attached to, that is the maxilla bone, hence called maxillary teeth. And also the teeth are attached to the vomer bone, the one which normally acts as a partition between the nasal passage. So the vomer bone also has the teeth. So teeth we have in the maxilla, that is upper jaw, and also the vomer. But these teeth are not useful for mastication. I mentioned about not for mastication, but they are used for capture. Once actually the insect being captured, now these teeth are used to prevent the escape of the insect. The mouth kept closed, and the teeth are actually acting as a barrier, preventing the what is called the exit of the captured insect. So that is the main function. They are not used for grinding, but for preventing the escape of the insect from the mouth cavity after they are being caught. So they are used for capturing the living. Now I mentioned about the tongue. The tongue is normally bifid and sticky. Now the terminal end is being divided into 2, bifurcated. Such a tongue is called bifid tongue. Such a tongue is called what is known as a bifid tongue. And it is always sticky. Just an adaptation to just make the insect stick to the surface of the tongue while it is flicked out. Now what are the components of the digestive system? In general, in all vertebrates, a special condition, or we have a general condition we can say. The digestive system consists of a long tube, what is called alimentary canal, and also the associated glands for digestion called the digestive glands. The associated glands for digestion called, that is digestive glands. Now let us see something about actually what is the nature of the alimentary canal. It starts with the mouth and ends with what we call cloaca. There is no separate anus and reproductive apertures. The digestive aperture, the anal, actually the anal aperture we can say, not anal here, as the digestive opening for the elimination of undigested waste. Then the reproductive actually duct, as well as we have the urinary tract, all open into a chamber. That chamber is called cloacal chamber, and that one is opening outside by means of what is called cloacal aperture. So there is a condition here. So let's proceed with what we have. What are the components? Now the alimentive canal. So normally one of the adaptations in the case of herbivorous animals when compared to carnivores. Herbivorous animals have a long coiled intestine. Long coiled intestine. Because they have to digest cellulose. The digestion of cellulose takes place just not within a short period. It takes more time. It is being gradually digested. That's why in the case of herbivorous animals, the digestive system, particularly in the intestine, is very long. In contrast to this one, in the case of carnivorous animals, as they are feeding on mainly the flesh, the digestive system, particularly the intestine, is very short. See, because the frogs are carnivores, and now the length of the intestine is very much restricted or reduced. Then what are the components? We have the mouth. The mouth opens in the buccal cavity. No teeth in the buccal cavity, we have only the teeth. The buccal cavity is present, actually the buccal cavity is present, teeth I mentioned already. But in the mandible, the lower jaw, the teeth are absent. We have only maxillary teeth in the upper jaw and also in the omarine teeth. The teeth present in the omer bone is called omarine teeth. Now this one, mouth, the buccal cavity leads into a short esophagus, not a long esophagus. Now the esophagus opens into what is called a stomach. It is somewhat elongated and tubular, and which continues as what we call the intestine, and then rectum, and finally opens outside by the cloaca. So we have mouth, buccal cavity, a short. So in the buccal cavity there are no digestive glands. One of the special characters in frog or amphibians. Digestive glands are absent in frog's buccal cavity. Remember, this is one question also. No digestive glands in the case of frog. We have digestive glands, but digestive glands are completely absent. So we have the mouth, buccal cavity, a short esophagus, a long tubular stomach, and followed by the intestine. Then we have the rectum and the cloaca, the common aperture for digestive, excretory and reproductive materials. There is only one aperture, that is called the cloacal aperture. Now the whole of the alimentary canal, if you are taking a section, as in the case of human being, is being formed of 4 layers. If you are taking that one, 4 layers. In the case of human body, you know that one. If you make a section of the alimentary canal, the wall being made up of 4 just actually structures or 4 layers. From outer to interior, I'll tell you just we have outer serosal layer. Then we have muscular layer, then submucosal layer, and then mucosa. So we'll talk about later now one by one. Now this is the digestive system showing the various organization of different the organs in the system. Now we have, this is what we call the buccal cavity. This is the buccal cavity. We have a short esophagus, not very long. And this one is leading into what we call the stomach. This part is the stomach. The stomach is followed by, you see that one, the intestine. The intestine, you know, as usual in our case, also differentiated into duodenum and then ileum. And that one is not represented. We have the duodenum, and followed by simply we can say mesenteron, or we can say ileum region or small intestine. The small intestine is followed with the large intestine. That large intestine is in the form of what is called the rectum. This is the rectum. Rectum, which opens into the cloacal opening or the cloacal chamber by means of what is called an aperture. So that is what is called the cloaca. We cannot say the cloaca or the aperture. It is a chamber into which 3 openings are actually open. One, the reproductive aperture, another one, the digestive aperture, and the last one, the excretory aperture. All being open only in a chamber called cloaca. And that one opens outside by means of a single aperture, that is called cloacal aperture. Now we have the glands associated or nothing with the liver. Here I represent the liver. This one is the liver with the gallbladder. And also we have the pancreas found in the lumen, or we can say in the loop of the intestine. That is between what we have the stomach and duodenum. There is a loop formation, and that is the place of location of the pancreas. We'll discuss one by one. This is the picture showing that one. Now this is another picture with the color. So you see that one, a separated and isolated one. This is esophagus, starting from the buccal cavity. Then this is a tubular stomach, and followed by this is the intestine. The intestine is enlarged from the rectum. So we don't have any ileum. Simply some cases in stomach it is given this is the duodenum part. The curvature that is normally formed, the first part of the intestine is called duodenum, the place of digestion. But generally speaking here it is only a small intestine, highly coiled, which is continued as the rectum. The rectum opens into the cloaca, from where it is being sent out the waste materials. Now this is the liver formed of two lobes, and it secretes a secretion called as a bile, which is being stored. Let's come to this later now. Now these are the paired kidneys not associated with the digestive system. This is viscera. Once we are cutting over the body, you can see all the organization of the internal ones. See, we have the liver, the digestive system, and also that is the kidneys, etc. all being present only in the body cavity, together called as a viscera. And also we have, I mentioned, we have the urinary bladder. Now this is the area rectum. Now the urinary bladder also opens inside. Now the ureter, having the ability of transferring the reproductive materials, also open into that one. So three openings into the cloaca, the chamber, from where all being sent out through a single aperture, what is called cloacal aperture. So don't confuse with the cloaca and cloacal aperture. Now what are the associated glands? We have the digestive glands in the form of either liver or pancreas or intestinal glands. Liver, pancreas and intestinal glands. These are the three digestive glands. But you see, I mentioned about, this is one peculiar question, salivary glands are completely absent in the buccal cavity. No salivary glands. Remember that one. We have three pairs of salivary glands. Even in the case of rabbit, they have four pairs of salivary glands. But in the case of frog, the salivary glands are absent. Now the second one, we have the liver. The liver one concerned with the secretion of bile. In our case also, the fluid secreted by liver is called bile. Now it is not an enzyme. So which one of the following organ or which one of the following juice contains no enzymes? Now the bile is a fluid secreted with the liver. It doesn't contain any enzymes. No enzymes present in bile, but it is used for the breakdown of fat, a process called emulsification. So large fat molecules are being broken into small fat globules by the action of what we call the bile, the one which contains some salt. That salt is responsible for the breakdown of the fatty molecules into smaller fat globules. That process called emulsification. We'll talk about in physiology in our case. So anyway, we have the liver. The liver is normally concerned with the storage of what is called the bile in a sac-like structure. The name of the sac is called gallbladder. Now another gland which is found in the loop of what is called the duodenum, or the first part of the small intestine and the stomach, that is the pancreas. That's the second one. And it produces pancreatic juice containing all the enzymes for the digestion of fats, then carbohydrates and also proteins. Then we have also the wall of the intestine internally. If you make a cross section of the intestinal wall, the walls contain a number of glands. The glands are responsible for secreting the enzyme, what we call the intestinal juice. The glands present the wall of the intestine concerned with the secretion of enzymes. All together, intestinal juice is called crypts of liver pool. So even in case also, this is present what we have the submucosa of ileum. Submucosa are actually the mucosa of ileum. In our case, in the intestine, we have these glands we'll talk about later under the digestive system. It is called intestinal gland, a small pits containing a number of glandular cells which secrete what we call the juice. That juice is called intestinal juice. So the pancreas secretes pancreatic juice, the liver secretes bile, the intestine secretes what we call intestinal juice. In addition, the stomach, the wall of the stomach secretes what we call the gastric juice. In the wall of the stomach, we have one peculiar cell. That's also one question. A peculiar cell present in the wall of the stomach that is concerned with the secretion of hydrochloric acid. And that cell is called oxyndic cells. So the cells which secrete hydrochloric acid to maintain acidic pH, because the gastric juice contains some enzymes, particularly protein digesting enzymes. These protein digesting enzymes are capable of working only in an acidic pH 1.5 to 2.5. They need an acidic pH for their action. That is why the gastric juice contains hydrochloric acid secreted by what we have one cell present in the gastric glands, what is called oxalic cells. So the oxalic cells of the gastric glands present in the wall of the stomach secretes hydrochloric acid. This is one question, the entrance question, just regarding our physiology. Name the cells which secrete what is called hydrochloric acid. There is also another name for these oxalic cells, parietal cells. They are also called parietal cells. They are also called parietal cells. So we have oxalic cells or parietal cells concerned with the secretion of hydrochloric acid. Because to make the medium acidic for the action of enzyme, so there is one peptic enzyme secreted in the stomach, what is called pepsinogen. The pepsinogen is an inactive form of enzyme that is being converted into active pepsin that is brought about by what is called hydrochloric acid. So the stomach glands secrete hydrochloric acid with the help of oxalic cells. There is another type of cells what is called enzyme secreting cells, they are called peptic cells. These peptic cells secrete one protein digesting enzyme what is called pepsinogen. So any word ending with ogen, this is what is called an inactive enzyme, pepsinogen, chymotrypsinogen. And once they are being activated, then they are called pepsin. Suppose once it is activated, the enzyme is called pepsin. So the activated enzyme is called pepsin, the inactive enzyme is called pepsinogen. See the precursor, the basic substance. So normally this pepsinogen gets converted into pepsin by the action of hydrochloric acid. So this is inactive enzyme gets converted into active pepsin with the help of hydrochloric acid. I will give more detail in our digestive system. We are going to talk about the next one soon under the physiology of digestion. So anyway, now in the case of from two types of cells in the stomach, one is the oxalic cells, another one what we call the peptic cells. The oxalic cells secrete hydrochloric acid. The peptic cells secrete an enzyme what is called pepsinogen, which helps in the digestion of proteins. So these are all actually the various glands and the parts connected to the alimentive canal. Now, what is happening? In the stomach I mentioned about we have the hydrochloric acid and also pepsinogen, a proteolytic enzyme. Now the hydrochloric acid converts pepsinogen into active pepsin. That one is responsible for the digestion of proteins. So in the stomach we see that one, the digestion is initiated with the help of hydrochloric acid and gastric juice. In the gastric juice only we have the pepsinogen that is responsible. So what do you mean by gastric juice? The various fluids secreted by different glands together form gastric juice. Particularly the enzyme plus hydrochloric acid together form gastric juice. So it contains a protein digesting enzyme pepsinogen for the digestion of proteins. Now in the stomach the digestion is not completed fully, even in our case also. In our case also the food being digested partially, then we have received a semi-solid food. That semi-solid food that is formed in the stomach is called chyme. This is the same thing happening in our body too. Chyme, semi-solid food formed after partial digestion. Now it passes through the stomach, passes from the stomach to the first part of the intestine. The first part of the intestine is more or less in the form of U-shaped structure, what is called duodenum. A U-shaped structure called duodenum. It is a place of digestion. In our case also it is a place of digestion. The food bodies are being broken because of the release of the bile from the gallbladder and also the release of pancreatic juice from the pancreas. Both open directly into the duodenum. Now the duodenum receives, I mentioned about bile, that is from the gallbladder. Then the pancreatic juice, that is from pancreas, through what is called a common bile and pancreatic duct. So to begin with, we have a bile duct coming from the gallbladder and a pancreatic duct coming from the pancreas, both joined together to form a common duct which opens into the duodenum, pouring their secretions into the duodenum. This is for digestion process. Now what is the role of bile? The bile emulsifies the fat. That is what's called, it brought about, it brings about what we call emulsification. So what is actually emulsification? We are taking large fat molecules, So they cannot be absorbed by what we call the wall of the intestine. so that they should be broken into small, what we call fat globules. This process of formation of fat globules from the large fats with the help of bile salt of the bile is called emulsification. See, if you are taking a colloid, there are two types of colloid. If you take a colloid, there are two types of colloid. So what is a colloid? A suspension of one medium into another to form a solution. So normally a colloid consists of a solute and solvent, and that is called as a colloid. There are two types of colloid. You know that one. There are two types of colloid. One type is called emulsion. One type is called emulsion. Another type is called emulsoid. These are the two types of colloid. The example for emulsoid, for example, sugar in water or salt in water. Sugar dissolved in water. Sugar in water. I'll take it that minute. Sugar in water. So here the dispersal medium and the dispersal phase. That means the dispersal phase is solute and the dispersal medium solvent thoroughly mixed with one another. So you can stir the sugar in water, completely it is being dissolved. So that one is emulsoid, having both the dispersal phase and the dispersal medium combined together, dissolved together to form a solution. But in the case of emulsion, the solute, what is called the dispersal phase, the solvent, water, the dispersal medium, do not mix with one another. Say an example of oil in water. Oil in water. This is an example for emulsion. So the formation of emulsion is called emulsification. So when you're pouring oil in water, it is floating. Likewise, we have the intestine. Here we have the large fat particles are taken into the lumen of the intestine, where we have the release of the bile salts, which break this one into small globules like this. And these are all floating in water. So this is a mixture of what we call the fat globules and water. Then only the fat globules are being digested by another enzyme, what is called lipids. So here the formation of fat globules by the action of what we call the salt present in bile is called emulsification. So emulsification, the formation of emulsion. Now the oil particles like the fat globules are floating in water. So a mixture of oil particle or fat globule plus water. That is called the emulsion. That emulsion is being formed by the action of what we call the bile. Hence called, you see that word, emulsification. So the main function of the bile, it doesn't contain any enzyme, but it helps in the digestion of fat by causing emulsification. So no digestive juice in the case of bile, but it helps in the digestion of fat by causing emulsification. So bile emulsifies fat, and pancreatic juice digests almost all the proteins and carbohydrates. It's a mixed enzyme juice having enzymes for the digestion of carbohydrates and also for the digestion of proteins. So as a result, what will happen, the food is completely digested. Then we have the wall of the intestine, we have in the ileum region. The inner wall of the ileum is raised into many finger-like projections. Suppose you are making what we have. This is a cross section of a digestive system. The inner wall being reduced into, you see that one, finger-like projections. So these are all the finger-like projections. These finger-like projections are called villi. These finger-like projections are called villi. They assist or help in absorption of food by increasing the surface area. Now if you are taking just each villus, each one is formed of single layer of epithelial cells. And if you are enlarging one epithelial cell, now this is one epithelial cell, the free margins of these epithelial cells have minute hair-like projections. Now this is the epithelial cell lining also, this is one cell enlarged, this is one villus enlarged. Each villus has a single layer of epithelial cells, and each epithelial cell is a columnar epithelium having free margins like many filamentous hair-like structures, and they are called microvilli. So the microvilli and villi, they increase the surface area of absorption. Now the villi are considered as a unit of absorption present what we call in the intestine. We will discuss more and more in our system. the next system, the digestive system in humans under physiology. Now, digested food is absorbed by the villi and microvilli. Microvilli are minute hair-like structures present in each cell, and villus, it is formed by the combination of many cells, a single layer of cells, a projection, a finger-like projection formed from the inner wall of the intestine. Now, the undigested solid waste moves into the rectum, and where it is being stored for a while, and that is eliminated through the cloacal aperture. This is what we call physiology of digestion. The role of bile, the role of pancreatic juice, the role of what we call actually intestinal juice, and also the role of gastric juice. So these are all the 4 juices involved in what we call the digestion of food materials in any vertebrate, including human beings. Now, the respiratory system. What is the nature of the respiration? So the animal has a different types of respiratory organs, either in the form of skin or in the form of what we call the buccal cavity or in the form of lungs. So 3 different types of respiratory organs are present. Accordingly, we have cutaneous respiration, buccal respiration, and then pulmonary or lung respiration. Now, frogs respire on land and in water. While in water, it respires by 2 different methods. So, when in water, the animal respires mostly by using the skin. When on land, it respires by all the 3 types: skin, then buccal cavity, as well as what we call just the lungs. So, when respiration occurs in water, it is because of that is skin. Skin acts as an aquatic respiratory organ, not the lungs. The animal cannot take in oxygen in a dissolved condition of water. So, in water, the animal respires only with the help of skin. Such a type of respiration is called cutaneous respiration. Nearly 35% of the respiration is of this type. Only 65% is by other types of respiration. Mostly, for example, we have the buccal respiration least percentage, and then the pulmonary respiration more than 64%. Okay, now the respiration in water is brought about mainly by the skin. Such a type of respiration is called cutaneous respiration. It accounts for nearly 35% of the total respiration. Now this is the respiratory system. Normally we have a pair of lungs. Then we have, this is the tracheal region. So a small, normally elongated tubular pink colored lungs are present in the thoracic region. We cannot say thorax, that is because the absence of neck. So there is no differentiation of thorax and abdomen. We can say simply the trunk. The body part which is not differentiated into thorax and abdomen is called the trunk. Now we have pair of lungs. So the left one, the right lung, and then we have a common trachea. And we have the mouth, then buccal cavity leading into a small, just actually larynx, and which is leading into what we call the trachea, which ends in the sac-like spongy, just not spongy structure, sac-like, actually somewhat a balloon-like structures, not spongy in nature, called what we call the lungs. Very similar organization that is of frog. Now, when animal is in water, the type of respiration is called cutaneous respiration. The animal takes in oxygen through the skin, the moist skin, because the skin is richly supplied with the blood. So, through skin, the oxygen is taken in and carbon dioxide is taken out and being supplied to what is called the blood through the blood vessels. Now, when the animal is on land, the animal respires by using 3 types of respiration. One, the buccal respiration of least account, say an example of 0.9%. And also by using the skin, because the skin is always moist, provided with the mucus gland assisting the cell respiration. Okay, that is skin. And also pulmonary respiration, nearly 64%. So 35% by means of skin when animal is in water or on land totally. That is called cutaneous respiration. Through skin, 35%. When the animal is either in water or on land. Then buccal respiration only when the animal is on land, nearly about 0.9%. And the maximum respiration takes place only through the lungs. It is up 64%. So the question is, what is the main type of respiration in the case of frog? That is pulmonary respiration happens through lungs. Next one only we have the skin. Now the lungs are a pair of what I described the structure, elongated pink colored structures. A sac-like one, not a spongy one, sac-like structure, and present the upper part of the trunk, which assists in respiration process. Now, during peculiar situations, abnormal situations or unfavorable conditions, the animal respires only through the skin. For example, the animal just is going to sleep during winter. That is called the winter sleep. That means the animal doesn't do any activity. It is simply taking the rest and utilizing the energy stored in the body fat by means of metabolism energy being released. So that kind of sleep, the resting stage during summer is called the summer sleep or estivation. The summer sleep is otherwise called estivation. This is one person. Similarly, during extreme cold conditions, the animal is taking rest. That is called as a winter sleep, and that is otherwise called hibernation. So these are the two questions: estivation, otherwise called as a summer sleep, a resting stage, or we call hibernation. That is during what we call during winter, and resting stage during winter is called hibernation. Okay, that's about what we call the respiratory system. We have three different types of respiration: the cutaneous by skin, then pulmonary by lungs, and then buccal respiration through the buccal cavity. Because the buccal cavity is also, that one supplied with the rich supply of blood vessels. So the exchange of gas is possible when the air is passing through the buccal cavity to reach the lungs. So the major type of respiration is by lungs, 64%, and the next comes you have the skin. The skin is being used for respiration both in water as well as on land. So with this I conclude about the respiratory system. We have to go for the vascular system, the circulatory system. That is in the next class. Okay, thank you.